Hello everybody, today we're going to talk about ions. What's an ion? Well, atoms tend to gain, lose, or share electrons when in a chemical bond. So they're gaining or losing. An ion is something where the number of protons does not equal the number of electrons. But you can never, ever, 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 ever gain or lose a proton. So if we look at chlorine, when we look at chlorine, just looking at the periodic table, we can see that chlorine has 17 protons. So typically, when it's on the periodic table, it has 17 protons, and it has, 17 electrons. However, when chlorine goes into a chemical bond, it tends to gain an electron. So it tends to go up to 18 electrons. So it has a different number of protons than it has electrons. So you'll notice there are more negatives than there are positives. In fact, there's one more negative than there is a positive. So 17 of them balance, but then I've got one extra one. All right? So I would say that chlorine has a negative charge. All right? Because it has one too many electrons. Now you can still write the 17 and the 35 out here, that's fine. But the important part we're talking about today is the negative charge that's out there. Now, similarly, if I look at sodium, sodium typically, when you look on the periodic table, has 11 protons and 11 electrons. However, sodium tends to lose one electron. All right? So it would have 11 protons, but it would only have 10 electrons, so 10 of them would balance, but then I have one extra proton. All right? Or one too few electrons. Look at it either way. But the bottom line is you've got a positive charge. So I would write this as Na with a plus sign. Now you could write 1 plus, or you can just write a plus sign. It really doesn't matter. But it currently has a 1 plus charge. All right. So let's look at magnesium. What's going to happen when it loses 2 electrons? Well, it's going to have 12 protons because it's number 12 on the periodic table. It only has 10 electrons, so it has way too many protons. In fact, it has two too many. It has 2 more protons than it has electrons. So it's going to have a positive charge, but it's going to have a 2 plus positive charge because it has too few electrons. Right? So it has 2 more positives than it has negatives, so it's going to have a 2 plus charge. How about sulfur? Sulfur gains 2. So it's going to have 16 protons, but it's going to have 18 electrons. So it has too many negatives, so it's going to have a 2 minus charge for sulfur. Okay. All right, pause the video and try this one. Okay, so it has 13 protons, and it only has 10 electrons. So it has 3 more positive charges than it has negative charges, so it takes on a 3 plus charge. All right, how about phosphorus? Phosphorus has 15, so it has 15 protons. 15 protons. And how about electrons? Well, it's taking on a 3 minus charge, so it picked up 3 more negatives. Remember, we can never change the number of protons. The protons is always whatever this number is, whatever number is on the periodic table for phosphorus. So here we have a 3 minus charge, so we would write it this way: phosphorus 3 minus. It has 18 electrons and 15 protons. All right, I can write these all sorts of ways. I can write it as chromium 52. So when I write it as chromium 52, the 52 doesn't matter when I talk about an ion. I have to figure out what the atomic number of chromium is. So I go to my handy-dandy periodic table and I look up chromium. So I find chromium, there it is, and I see that it's number 24. 24 is what I care about. So I come down here and I take chromium, which is number 24, just kind of to remember it, and it takes on a 3 plus charge. Right? And we're going to put this number up there. It's called a mass number. We're just going to put it up there. And it has a 3 plus charge, which means that for protons, I have 24. Remember, your protons always must remain whatever chromium is. But your electrons is what's changing, and I have 3 more positives than I have negatives. So I only have 21 electrons. All right, how about nitrogen 14? Again, because it's nitrogen, I have to go look it up. And for nitrogen, I find nitrogen way up here on the right. And I notice that it has 7 protons because it's atomic number 7. So I would write nitrogen as nitrogen with a 7 down here and a 14 up there. And that means it has, and it has a 3 minus charge, sorry. And for protons, it has to have 7 because that number always must match the atomic number. And the electrons, I have 3 too many electrons. I've got more negatives than I have positives. So I've got 10 electrons. Okay, so what I would like you to do is I'd like you to pause the video and look for these things on the periodic table. Pull out your handy-dandy periodic table. And if you don't have one, look in the book. All right? No excuses here. And then come back and we'll go through it. Okay, looking up iron, I found that iron is number 26. So that's these two right here. That's real simple. Now, because it has a 2 plus charge, there have to be more positives than there are negatives by 2 of them. So remember, your protons are positives, your electrons are negatives. You have to have 2 more positives, so that would be 24, and this would be 23. Aspartame, that's not right. AT. Where is AT on the periodic table? Hopefully you can find it faster than I am. There it is. AT is way down the bottom right. That's number 85. 85. So that means it has to have 85 protons. But you'll notice it has a 1 minus charge. It has an extra negative. So it has an 86 electrons. How about SB? SB is down at the lower right as well. It's number 51. That tells me it has 51 protons. And because it takes on a minus 3, it has 3 more electrons, 3 more negatives than it has protons. How about zinc? Zinc is number 30. That's a very common one we use a lot. And it has a 2 plus charge, so that means we can only have 28 negatives because there have to be 2 more positives than negatives. Right? And our last one is tellurium, Te, which is number 52. And I've lost my pen. Hello, pen. Where are you? Thank you. 52. And it has a 2 minus charge, so it has to have 54 electrons. It has to have more electrons than it has protons because it has more negatives than positives. Okay, so what happens if I tell you an ion has 8 protons and 10 electrons? What do? Well, you look at the 8 protons, and you say, well, with 8 protons, I have to figure out what that is. So I go to my handy-dandy periodic table, and I look for the number 8. And I come over here and say, oh, number 8 is oxygen. Cool. So if number 8 is oxygen, that's number 8 oxygen, and it has 8 protons, and has 10 electrons. So what kind of charge am I going to have? Sure, I'm going to have a negative charge because I've got more negatives than positives, and I have 2 more, so it has a 2 minus charge. All right, how about this one? It has 20 protons and 18 electrons. How about that one? Well, again, I go to my handy-dandy periodic table. I look up number 20. There's number 20. It's calcium. This is calcium, and it's number 20. And so it has 20 protons. And my electrons, it can only have 18 electrons. That means it has more positives than negatives, so it's going to be positively charged, and it's positively charged by 2. All right, so let's go ahead and work through these. Again, what I'd like you to do is pause the video, see if you can do these on your own, and then come back and I'll go through each one with you. Okay, number 47. Number 47 is Ag, which is silver. And I notice there are more electrons. Remember, your electrons are negative, your protons are positive. There are 47 protons, 46 electrons, so there's 1 more positive. This is going to have a positive charge. You can write 1 plus or plus, it doesn't matter. They are the same thing. If I look at number 79, 79 is right below 47, and that's gold. Gold's number 79. And if I look at gold, it has 1 more positive than it has negative, so this is going to be positively charged as well. Now here, whatever this is going to be negatively charged because I've got more negatives. So I have to look at number 35. I look at number 35 on the periodic table, and I come up with bromine. Bromine is number 35, and it's negatively charged because I have 1 more negative than I have positive. How about number 82? If I look down at my periodic table, number 82 is lead. And you'll notice that there's a difference between 82 and 78 of 4. But there are more positives than negatives, so this has a positive 4 charge. All right, when I look at my charges here, it's going to be negative, and it's going to be -1 because there's only a difference of 1. I have to make sure I figure out what 53 is. 53 is iodine. 53. And it's going to have a negative charge because there's 1 extra electron compared to the number of protons. And my last one's going to be 83, which is right next to lead, and that happens to be bismuth. Bismuth is number 83, and there are 3 more positives than there are negatives. So that means I have to have a 3+ charge. Okay. You'll notice I wrote +4 up here. I should have written 4+, but at this point, that really doesn't matter. Okay, just go with it. All right. In summary, given an ion, you should be able to determine the number of protons and electrons in that ion. And given the number of protons and electrons in an atom, you should be able to determine the atom or the ion and the charge. So, go do the worksheet, ask questions if you have them. Hopefully you remember to take notes. I'll see you in class. Have a great day.